Grade 12s, we are looking at a cam drawing from paper 2, question number 2, and there is a motion of a cam starting at its maximum, not the minimum. The maximum is normally on top and the minimum is at the bottom, and the maximum displacement and rotating at constant velocity imparts the following motion to the follower. So we're going to skip that a little bit and we're going to go to the instruction. You have to draw, according to bulleted point 1, the displacement scale of 1:1 and the rotational scale of 144 millimeters equals to 360. And you need to complete the displacement graph for the required motion. Knowing that we have 140 for the full 360 and the fact that we have 12 spaces in 360 degrees, having slots of 30, we will take 140 and divide that by 12. So these slots at the bottom here will be 12 millimeters, which will represent 30 degrees. You then need to label the displacement graph and indicate the rotational scale. You need to show all the necessary construction. So here you're only going to draw the cam displacement graph according to the given information. Once you have drawn the graph and you've set it up with the 12 spaces, it states clearly in the first bulleted point that it descends 10 millimeters with uniform motion over the first 60. So for the first 60, it's going to drop from its highest point by 10 millimeters over the first 60. And the uniform motion will be a straight line. Then it descends further by 80 millimeters to the minimum displacement with simple harmonic motion over the next 90. So the simple harmonic motion is a motion where you're going to have a construction of the semicircle. There is then a dwell period for the next 30 where the cam doesn't move up or down. It remains constant. Bulleted point number 4, then it returns up by 60 millimeters with uniform acceleration and retardation over the next 90. So there is the construction where you are going to do the divisions 6 by 6, 6 verticals and 6 horizontals. Then there is a dwell period for 30 where it is constant and has no movement. It then returns to its original position with uniform motion, which is a straight line over the rest of the rotation. Let's put all of this in action on our cam displacement graph.